Welcome back, everyone, to COBOL Fridays. It's been a while, but we are excited to be back. And today we're going to have Roland Koo talking to us about modernizing COBOL applications on ZOS. Without further ado, Roland, I know you're an expert in this topic. We can't wait to hear from you. Thank you for being here on COBOL Fridays.
Yeah, thank you, Susanna. Good morning, good afternoon, or good evening, wherever you are. My name is Roland Koo. I am the offering management lead for enterprise product and compilers on Z. So today I'm going to be talking about modernizing COBOL applications on ZOS. So before I talk about modernization, there's really two aspects that, for modernization. One is obviously, you want your application to perform well. So performance is one of the aspects, and also, and also the facilities that you can use to extend your applications or extend the capabilities of your applications is also very important. So today I'm going to be talking about all these two aspects, and also wanted to also talk about some of the new languages, because modernization now is not going to be necessarily contained with using one single language, but also now you have the flexibility of using the language that best fit what you want to do. So I'm going to go over that as well. So first of all, let's talk about application performance and the hardware. What's the relationship? So if you look at the pie chart on the left, right, that is what we are used to before, because almost all the performance of your application performance actually came from the hardware. The reason is because we can increase the clock speed. I mean, if you can imagine, from less than 1 gigahertz to 5 gigahertz, everything on it, like if you move your application to new hardware, it will automatically run faster, right? So there's nothing that you need to do in your application yourself. But for the parts that we wanted to, lower the overhead of the application, whatever, that kind of stuff, we traditionally would turn to writing those, applications in assembler, and it will also work with COBOL and everything else. So this is really the the before scenario. And if you use middleware like Cakes, IMS, DB2, you will get performance improvements from the middleware itself. So you don't really have to worry about it. But because we cannot increase the clock speed forever, right? There are physical limitation in physics that won't allow us to do that. What we're doing now is we're going to be using a combination, of hardware features and compiler exploitation to be able to increase the performance of the application. So in this case, really, we're going to be looking at every release of the hardware. We actually, the compiler team is working very closely with the hardware team to actually look at the COBOL workload and figure out how we can jointly improve the performance of that workload, right? So we're going to be using hardware features. By using hardware features, which means that you need to have the right instructions in your application to be able to take advantage of these features, right? So as a result, you will have to pay a little bit more attention to your application, and the hardware will still give you a little bit more, boost, but that effect is going to be a lot less than before. And if you're using middleware, you don't have to worry about it, because middleware always have performance in their roadmap, right? That doesn't change at all. So the easiest way for you to improve performance is, you may want to, you want to recompile your application with the latest, COBOL compiler. And you not only just recompiling it, but you really need to optimize it as well. And optimization technology is going, actually requires the application to be pretty well, fairly well structured. So if that's not very well structured, then maybe you need to consider to refactor some of the parts of your application. And this is also unique for System Z, because for the Z hardware, because we're really because COBOL is a very important workload, on this platform, and COBOL is still the best language for writing business applications, and the Z platform is probably the most secure and has the best bandwidth, and there's a lot of advantage of running these applications on a platform. So this is really our roadmap moving forward, is to have is to deliver the performance of application performance with a combination of hardware and compiler support. So I just wanted to give you a little bit of example of what I just talked about. This roadmap actually started from Z10 when we first put in the decimal floating point unit. We know that there's a lot of decimal arithmetic that's being handled by COBOL applications. So we're finding ways to speed that up, to speed those calculations up, right? So we put in this feature in there, but we know that if we put in a new feature and we have to get customers to go and change a lot of their programs to take advantage of it, that's going to be a non-starter, right? So in EC12, what we did was we actually did a hardware conversion, put in some instructions to the hardware to be able to convert zone decimal, which is really your PIC 9 in arithmetic in COBOL, right? PIC 9 data type in COBOL. And this data type is very inefficient because it does not have any arithmetic operations that's associated with it. So anytime that you do any calculations using the PIC 9 arithmetic, you will have to convert it to pacdecimal. And then after you've done the calculation, you have to convert it back. So it's very inefficient. But so what we did in EC12, ZEC12, is to put in a few new instructions, again co-designed with the hardware and compiler team, to put in something called a decimal floating point zone conversion facility. So instead of having you to code for to exploit the decimal floating point unit, the compiler will actually find opportunities and use these instructions to convert the zone decimal data type to decimal floating point, because decimal floating point unit has its own, obviously has its own arithmetic instructions, has its own registers. So it's going to be able to do this calculation a lot faster, right? So, and then we also have an instruction to convert it back. So in EC12, we really sped up the performance of PIC 9 calculations, right? And in Z13, we extended the same concept, but we're actually we're now converting pacdecimal arithmetic as well. So same deal, like pacdecimal arithmetic, although it has its own arithmetic operations, but it doesn't, so there's a lot of inefficiencies in it, because there's a lot of memory-to-memory instructions in it. So we're trying to, to avoid that. And also in Z13, with the vector infrastructure, we also made COBOL, within spec statements, we actually generate, for string manipulation, we actually generate vector code to speed up the application as well. Now Z14, we actually designed a totally new unit called the vector pacdecimal facility, because we're still not happy with the conversion. We're still not happy using with a lot of the memory-to-memory instructions. So what we did was we used the vector registers, and so we don't really have it. We can eliminate all the overhead from memory to memory. So it really speed up the calculations for pacdecimal arithmetic. And then with Z15, we enhanced that to basically do that's a new unit coming out of Z14, and we've basically fine-tuned it, and we actually reduced the overhead for interlanguage calls that has some exception, conditions coming in, and we made it run a lot faster. So this is really the roadmap of the Z hardware, for COBOL applications. So it's really important that you would stay current with the compiler every time you actually upgrade the Z hardware. So another aspect is, we know that a lot of customers are digitizing, their businesses, right? To make it, to bring the application closer, to their customers. So digital transformation is something that we also, it's front and center in our strategy. And we do it in two ways, right? One is we are going to be delivering new COBOL language features, right, to enable developers to extend their business critical applications, support new environments, right? Like if you wanted to bring your COBOL applications at closer to people using the web, mobile, or cloud infrastructure, we're actually putting in new language feature to enable you to do that, right? And we're also enabling very popular new programming languages on ZOS. We have enabled Node.js, Python, and we're working on Go right now. Basically, what we feel is that COBOL is very good at what it does, but so it really runs your business, right? So as you move into this digital transformation phase, you would like to find, you're not confined to write everything in COBOL, but we just want to make sure that whatever you do, with the COBOL application, you have the facility to actually extend it, right? To put in new features so that you can actually achieve your digital transformation goals. So here are the latest compiler offerings on the platform. On the left, they are pretty traditional, compiler offerings, which is COBOL, Automatic Binary Optimizer, which is really a sister product to the COBOL, and I'm going to go over it later on in the presentation. PL1 is still very strategic for us. We're actively working on it. C and C++ and Java, right? Those are languages that you are very familiar with on the ZOS platform. But lately, we also have added support for Node.js, Python, and we're working on Go right now. So I want to talk a little bit about, so I talked about exploiting the Z15 and things like that. Just want to give you an example of what kind of performance gains that you might get from the latest compiler. So the latest compiler, COBOL compiler, is version 6.3. It has all the facility to exploit the Z15 hardware as well as Z14 hardware and 13 and so on. So on the Z15, if you compare, using our benchmark suite, when we compared the performance with version 4.2, we're looking at about a 58% improvement. Now, our benchmark suite is more skewed towards the a numeric intensive one. So with the calculations, with the there's a lot of calculations in it and stuff like that. But there are some some I/O, some other things as well, but it's skewed more towards the numeric side, and we see about a 58% improvement. So if you're still on version 4.2, that's what you're leaving on the table. Might be right now. You're leaving up to 58% of performance on the table, right? And even if you have migrated to version 5. Version 5 is really the first delivery of COBOL compiler that is based on the new infrastructure. Then you're leaving about 26%, fully optimized. And even if you use 6.1, you're looking at about 21%. But if you're using 6.2, you're looking at 3%, right? So basically, we achieved this thing not just by exploiting the hardware, but we also put in new advanced optimization features as well. So the optimization technology will improve as we go along, as we follow the hardware roadmap as well. So with the 6.3 on Z15, we say that we have interlanguage calls, right? And if you hit some decimal overflow conditions, those you can actually those would be processed a lot more efficient than previous processors because we're putting in new instructions in the Z15, all right, to handle this rather than going through the language environment or going through a library. So you look at by about any of these handling would reduce CPU usage by about 20%. So I want to give you an example of what I was talking about, right? So if you look at this COBOL code, which is very simple, right? It's just adding two numbers to give you a result, give you another number, and if you look at this PIC9, so it is really zone decimal arithmetic. So with version 4, if you look at the left box there, it basically, we use a lot of in-memory instructions, and the instruction generated is not very efficient because every time that we do something, we have to make sure that we check the sign settings, right? That's, those are really, really old instructions that we put, like MVC is really a memory instruction, and then we have to check the sign, and then we have to do other things as well before we can even add it, right? So it's very inefficient. So with the EC12, what we did was, if you look at doing the same operation, we actually changed the instruction to convert it to running on the decimal floating point unit. So, but it still has some conversion overhead, but it's a lot better because we see about a 66% improvement in performance. But if you look at, if you use the vector packed decimal facility, which was first introduced on Z14, you actually see that we've used a lot less instructions. We're using the vector registers and no overhead. So we're talking about a 5 times performance improvement over version 4. So that's really the kind of things that we're talking about, and this is kind of things that we are, trying to target, every time, certain aspects of the COBOL workload, and make sure that we really take care of it because we know how important it is on the platform. So I talked about modernization features, and here are some examples of it, right? Way back in version 4, we put in native XML support. So basically what we did was we extended the language to natively, process XML documents, right? We put in new phrases like XML parse, XML generate. Not only you can, parse a document, but you can also generate an XML output from the data, from the data in your COBOL application. And in version 6, we extended that to JSON. Now, XML is mostly for the SOAP web services, and JSON is mostly for REST web services. And we basically use the same, follow the same syntax. And we now, it can actually parse JSON documents and actually generate JSON documents as well. We have added Java interoperability. So COBOL applications can call Java methods, and Java methods can call COBOL procedures and things like that. The mechanism that we use today is through OO and JNI services. So basically, those are not very popular amongst a lot of the programmers, because Java programmers would not want to touch OO and even COBOL programmers don't want to touch OO right? And JNI service is not Java, it's not COBOL, it's almost like a third language. So the interoperability is there, but it's not very friendly, to programmers. So what we're doing now is we're trying to redesign this Java interoperability part to make it easier, because we can provide some standard JNI services, so people don't have to touch COBOL, and don't have to write too many JNI services. So that's really the direction that we're moving forward, and that we are working hard on right now. UTF-8 in 6.3. This is a new feature for 6.3 COBOL. We added a new data type called PICU, and that enables direct processing of UTF-8 data. So today, like for example, if you store UTF-8 data in DB2, you wanted to process it, you have to convert it to UTF-16 and convert it back. That's very indirect, and putting this feature in there will help. It will simplify a lot of the programming effort. And also, UTF-8 is involved in a lot of natural language processing. So that would also help, people who has to process natural languages. But one thing, when I was talking at a conference in Australia last year, that was really interesting. One customer was so excited and tell me that, great, you have UTF-8. Now we can actually generate reports from all the, text messages that we send to customers, because part of their push is to improve the mobile, banking type application. This is a bank, and they send text messages to customers, And they don't think that, and customers don't think that it's a legit, text message if it doesn't have emojis in it, right? So when they store these, text messages as part of the customer record, when they generate this record, they always see funny characters. But now they're so excited that they can actually see the right emojis and everything else that's they send to customers. I thought that was pretty interesting. We also, with 6.3, we also introduced 64-bit support, which is really 8mos64, and you can compile it with LP64 option. And this is really the phase 1 delivery of 64-bit. We understand that customers are running out of addressing space because data is getting bigger and not smaller, and even JSON data is getting bigger as well. So right now with 8mo31 programs, you're limited to 1 gigabyte. You can only address 1 gigabyte of the data item. But with 64-bit now, you can do 2 gigabytes because it's the first delivery, and you can do multiple data items. So basically, you can expand that addressing mode. And 64-bit is really about addressing; it's not about performance at all. So that's and we're continuing working on to ease that limitations and put in more support for 64-bit. For example, like JSON is not support 64-bit, UTF-8 is not support 64-bit currently, and we're working towards undoing those kind of limitations. We also are looking at implementing some COBOL 2002, 2014 language features. Here's a list of things that we, sort of like examples of what we have done, like dynamic length elementary items, which is in 6.3, conditional compiler, which is in 6.2, allocate free, initialize, and table sort, and more. So we choose these language items based on customer input, and customers either open up a request for enhancement request, or at some point time to time we survey our customers and they would help us prioritize this list, and we'll continue on doing that. So I'm going to switch a little bit, switch gears to automatic binary optimizer, or ABO. So if you look at this is a sister product of COBOL version 6. COBOL version 6 has a very sophisticated optimization technology built in to the compiler. ABO is really the optimizer part of it, but instead of optimizing source, it optimizes load modules. This means that you don't have to do recompilation. So even your programs currently has any kind of invalid data, or items, or you have uninitialized variables. If you compile it with the compiler, compiler will catch every single one of those problems, and you will have to change the source. But with ABO, because it optimizes load modules, compiled with VS COBOL 2, 1.3, all the way up to 4.2, because it directly optimizes objects load module. You don't really have that problem. So basically, what we make this product to complement the versions, the COBOL compiler, because it can reduce, it can just help you reduce CPU for the code that you have not compiled for a long time. And it can actually lower the processing time. And it targets the latest Z systems from EC12 all the way up to Z15. All the optimization and exploitation features, will also apply to the ABO product. And the most significantly is that because it reduces, it doesn't change program logic, and it can actually reduce the migration effort. Or this migration scope, so that you can reduce effort for moving to 6.3, because you really don't need to work on the source itself. So I'm going to be talking a little bit about more how it works here, later. So here's how it works, right? The input to ABO is an original executable. So executables, we all know that they have they have multiple critical sections or CSECs in it. So ABO takes the original executable as an input. What it does is that it unbinds it and it recreates the program structure, which we call the intermediate representation. And then we run it through the COBOL optimizer, right? CSEC by CSEC. And then afterwards, we will rebind it and give you an optimized executable. So it does not touch source. At no point it will touch any program logic. And it's just a lot of checks in place to make sure that we have done our optimization safely. For example, if you have one of the CSECs that is actually, if you have one of the CSECs that is a kick CSEC, because ABO is a COBOL optimizer, so it will not touch it. It will just skip it, right? Same as assembler. So it only knows, basically, it will recognize what it can touch and what it cannot touch. And if it thinks that it cannot touch, it will just leave it the same way, right? So it does not alter any program logic at all. That's the result. You actually can, make it, because of the strong compatibility, you can actually significantly reduce the testing effort because you don't really need to run full regression tests. You just need to run some integration tests on it and make sure that everything still hangs. But be good to do some performance testing because the whole objective of this is to increase performance. So you want to do some verification of that. So because ABO takes a functional binary as an input. So if your binary is already working, for you for a long time, then we'll just, it will just take that and it will just, that is your starting point, right? And you don't have to worry about compile options because nothing is going to change. And we assure full compatibility. And that's why you can actually reduce the testing effort. So when we talk a little bit, about, we talk a little bit about the performance that COBOL has. Now, actually, if you look at ABO, we're looking at about a 50% instead of a 58% in COBOL. So it's actually, if you look at it, it's the performance produced by ABO on C15 is pretty much on par with the COBOL compiler, right? So it's and from time to time, ABO, because optimization is it's a CPU and memory intensive application, so improving scalability is very important to us. So with this new version, we managed to reduce the CPU utilization by about 53% and achieve a 30% reduction in memory usage over ABO 1.3, which is the previous version for very large module. So we're actually not just tackling very small modules or medium-sized modules, but we're really tackling very big modules as well. So so we think that we wanted to to stress that ABO and COBOL compiler are complementary. So really, when you look at a typical organization, we're looking at about many organizations do not compile their applications. 100% of applications regularly, right? So what they do is they only compile those applications that they change, right? They have to make changes to that require source changes, like adding in new features or maintaining the application. So a lot of it, like 80% of it, they have no compile plan. It just works, right? The last time you might, in this group of applications, the last time you compile it could be 10 years ago, right? So what we're suggesting here is, use COBOL version 6.3 as your production compiler, right? Use the new language features, right, to modernize your critical applications. And while you're at it, you turn on optimization so your code will run optimally. For the rest of it, do some performance analysis, because if you have COBOL, the 20% may not represent the bulk of your performance bottlenecks, right? So you wanted to do some performance analysis. So if your if a program calls another program, and calls another program, then you want exactly the entire chain to be optimized. So for the programs that are not compiled for a long time, we suggest that we use ABO. So that's how it works, actually complementary to each other. So I want to switch gear to talk a little bit about C and C++, which is an optional features of ZOS. Besides writing traditional C++, regular C and C++ programs, actually there's a mode in there that it's probably one of the best kept secrets of the compiler. Is called Metal C. It's an option that provides system programming capabilities. So there's ability to generate code that does not require access to LE, at runtime. So it is really ideal for modernizing assembly applications, right? Because what the compiler does is that it takes in the source code, and then the compiler will generate the assembly code for you, right? And then you can do it through the assembly, and then you can make executables out of it, bind it and make executables out of it. The biggest benefit here is that we know that trying to keep up with the architecture, keep up with the assembly code to achieve what you want to achieve, which is the best performance, is very hard, especially with the modern architecture changing every 2 years or so, right? It's very hard to keep up. So also assembler skills are getting a little bit more scarce these days. You have more people know about C than assembler. So allowing developers to use C syntax to develop system applications really shortens the learning curve, right? And the other benefit is that it comes with a minimum runtime, so it really does not have to go through the LD overhead. And because it generates assembler source, it seamlessly integrates to the assembly code base. So you can actually embed the assembler code within a Metal C program, and keep and iteratively modernizing it over time. It actually that would be one of the ways to to keep your assembler programs up to date, right? And the biggest benefit of all is you really have to develop, you only need to develop the application once and recompile it, for future Z architectures, and you will get full exploitation for it. The generated code may not be, as good as the, you manually write it, but it's a lot faster. So through one recompile rather than going off and recode. So it's more efficient. So that's really a very valuable tool to to modernize your assembler programs. So I do have a customer who is an ISV. They have a lot of assembler code, and what they did was they find it very hard to expand the team. So what they did was they basically took all the the best assembler talents and refactor the assembler routines and make them into core libraries, and expand the and make all the enhancements, the new enhancements, using Metal C. This way they can actually get more people to work on it, and also and keep the efficiency and the spirit of the application moving forward. So next, I want to talk a little bit about Node.js. So Node.js is is JavaScript, server-side JavaScript. So basically, you code in JavaScript, and your runtime runs on a server. So we have we have been working on Node.js for the past, I think, 3 years now, and we're very up to date with the community edition. So all these open source software that we enable on the platform, the first goal is to make sure that it stays current with the community edition, right? So we, what we did was, the latest edition is version 12 on the platform, which happens to be the latest edition on community edition as well. So these kind of offerings with the open source applications open source languages, they are all no license charge. It's, you can install it with SMPE. Because of the nature of Node.js, we put in a restricted use C and C++ compiler just in case that you need to pull down an NPM or make use of an NPM that requires a compilation. And you can actually optional, SNS is optional. So service as subscription is optional. So you can actually use it in production without any cost. But if you want support, you can optionally pay for it. And these new languages are currently not zip eligible, but it's eligible for tailor-fit pricing, because if it is a new workload, the idea of that is that you would increase the MSU usage, because it is new workload and it is a new application solution. Tailor-fit pricing, that additional workload will be subtracted off from the calculation of the MLC. So it's still going to be, kind of like free to you. So why Node? Node has a really, really big ecosystem, right? So they're winning the battle. They're leading in terms of the number of modules being available. So the good thing about this is those modules are already written and tested by other people, so you can actually use those modules to augment your existing IBM Z applications, and provide very timely response to customer requirements driven by digital transformation. Because it's such a competitive world that if there's any requirements comes in, they expect it to be delivered very quickly. And Node is actually a very good tool to help you to do that, just simply because there's so many Node talents around, programmers around the world. And also there's so many packages that's already available. So you just need to pick the right package, and then you can just compose. It's really not designing and writing application in the traditional sense like COBOL, but it's really composing the applications using whatever that's available for you. And all this is enabled on a Z platform. Node is Node everywhere, so there's no special, we did all the, enablement things, but your Node application and your Node development should be the same everywhere, no matter what platform that you're on. So of course, the reason why we want you to write Node, want you to write Node.js application on a platform is efficiency, right? So you can write it on other platforms, but when you want to access Node, ZOS assets, you have to come in through the network. But if you write it on the platform, then everything is going to be native. But to achieve that, we have to give you some facility to be able to access those assets, right? So here's a list of what we call NPMs that are designed to help you get the assets, to help you access the critical assets on the system. So that we, for example, ZOS Connect EE, it's really, Enterprise Edition is really a wrapper service for ZOS Connect. So, help Node applications discover and access Z resources, services that are enabled by ZOS Connect. Loopback, they help you expose APIs. ZDB2 allows you to directly, work with DB2 data using ODBC. Kix, with Kix TS version 5.5, it actually supports Node as one of the programming language, which is the same way that it supports Java and COBOL, because you can write write Kix applications with Node, and the entire application actually runs in the Kix TS region. Access to vSAM, right? Access to Rex, access to RACF and crypto and things like that. So this is sort of like a growing list of NPMs that we are enabling or make available, so that you can actually use the Node.js on ZOS. So we offer a Z trial. So all you need to do is to click on this link, And there are some scenarios they can try out with with exposing APIs with loopback connector, and there is Express, which is really a web server application. You can actually write some web applications. It's I'm pretty sure that once you try this thing out, you will find it behave the same way as it would be on other platforms. So Python, we have recently, I think in June, we made Python available on ZOS. This is really exciting because Python is almost like a Swiss Army knife of programming languages. You can do a lot with it. You can almost like do everything with it, really. Again, it is the same same setup as Node.js, no license charge, optional SNS, available in SMPE install. And the hardware prerequisite here is EC12 and up, and ZOS version 2.3 and up. The Python interpreter that we provide here, it would include the Python standard library plus some some PyPI packages like pip, NumPy, and things like that. Basic things that you will need to get started on the ZOS platform. And it runs on, it's a 64-bit application. It runs on ASCII. It supports ASCII and XP-Link, and it runs on the USS environment. So here are some use cases. We're new to this game, and we're still working with customers on really a lot of use cases, but here are the ones that we've identified so far. Obviously, new application development. We can actually, there's a lot of industry, packages that is available, like, for example, data analysis, GUI, APIs and things like that. There's, just like Node, but it's a little bit different than Node. It's more, a lot of it is more industry specific. So it's all that packages available. Again, you can enable new applications on the Z platform. Scripting is also very important because, for automation, automating tasks and workflows. So a lot of development tasks, like even, you can write a Python script to compare files, for example, if you're a developer, and doing your compiles and things like that. And, there's a lot of stuff that you can do with scripting, and automation is like, sky's the limit, because, automation is never enough, right? So Python scripts are really, really good for that. And as you know, that IBM is, is really, the direction is moved towards the cloud technology and AI and things like that. So obviously we wanted to look at the operation aspects of deploying applications, into the cloud, or deploying applications, into the corporate, infrastructure. So Ansible certified content for ZOS, allows you to connect IBM Z to a wider enterprise automation strategy, through the Ansible automation ecosystem. And this ecosystem is actually, you can, it's to enable this, you can use the de facto Python language to develop, playbooks and things like that, so that you can automate your and streamline your operations in your hybrid IT environment. So that's something that we are also, working on and delivering, so that we can actually get Z expanded into a bigger hybrid cloud environment. And Z open automation utilities. This is a set of utilities for ZOS, which is modeled after the standard Linux commands, and it's actually modified. It's actually equipped to work with ZOS datasets and file systems. So it's a really cool thing. And so, and this actually also supports the Python development, as well, to develop scripts and automation tools and programs and everything. So these are the kind of use cases that we see for Python so far, but obviously, we're just beginning. So we'll find out more as we go along. So I want to put the picture all together here. And about modernizing, right? So basically here is really, long time ago, you've been writing, business applications with COBOL or maybe other languages, and those applications might work with one need to work with some assembler routines, and you'll be accessing data through, vsam, db2, or IMS, right? That's really very typical, ZOS, applications. And later on, you may, use some of the, the newer things like the middleware, and all that. And that's, basically a lot of the critical application on Z will look like this, right? Then, then when web becomes, available, more dominant, then a lot of the applications, the COBOL applications, will be working with Java. They're extending the capabilities and work with Java. So that's why Java interoperability for us is so important, that, we're working on improving. And which assembly applications, a lot of customers are actually using Metal C to modernize it, right? So that it can be a little bit more maintainable, and also it's easier to get performance, out of the, when you move to a new architecture. Then we introduced Node.js, right? So you can obviously write fixed Node.js applications and working with vsam, db2, and all that. And you also, we talked about APIs. So, if you wanted to look at the API economy, you can actually use ZOS Connect to create APIs for CAKES, IMS, db2 applications. And you can use Node in this case. If you're dealing with APIs, Node would be a really good tool to orchestrate these APIs as well. The reason is because when you get an API call, right, in reality, it could translate into many calls. Like, for example, one customer, so a banking customer of mine, told me that, in order to calculate account balance, which is a calculated field, they have to go through at least 8 databases to get the information. So, imagine if you add another database to it, and you need to write it in COBOL, that's going to take some time. But what they're thinking about is really to handle all this thing with Node, so that, or APIs, so that they can just, it'll be a lot faster to do it that way, right? So Node is really good in orchestrating these, because, especially if it runs within ZOS, because you would like to get the people that understands the ZOS application infrastructure to actually lay out the APIs, and when you orchestrate it, you will like to orchestrate it on the platform, right? So the APIs is not just one way in, but it's also outbound as well. So if you have a COBOL applications that wanted to, get some information from the cloud, for example, you can actually go through ZOS Connect as well. So you actually have a two-way communication there. So this way, it is really good, because then the node can actually provide, when it orchestrates it, it actually can provide some program logic to it as well. So, for example, if I'm only asking for a zip code, you should not be giving me everything, like the address and things like that. So Node can actually filter all this, and it adds another layer of security, especially if it's going out to the to the cloud and everything, because you control what information is going out. So you added another set of security. You only give the application that's authenticated to use this this API the exact information that it's looking for, nothing more, nothing less, right? Then you have Python. Then you can actually write new Python applications, and Python, for example, if you want to do some data analysis and you want to feed that data analysis information to a COBOL application, you can do it through APIs, and Python is really, really good in doing APIs as well. Then you can, look at, then you can look at, integrating it to the world with the cloud, with mobile, right, with mobile devices and things like that. And IBM also provides something called API Connect that allows you to manage all these APIs as well. So I'm just trying to put together kind of like a possible picture, or as to how application can be modernized, or especially COBOL applications can be modernized, to work in this kind of a world, a very interconnected world, and without wasting any duplication of effort in writing similar applications and propagating everywhere on every platform, but you can actually rather use the critical application, expand it out, expand the capability, with APIs, with the new programming languages, so that you can actually get there a lot faster and a lot less risk. So lastly, I want to talk a little bit about Go. Go is it's in the works now. We're working on it. We put out a statement of direction that we're working on it. Go is a very important cloud infrastructure language, right? And especially in containerization, OpenShift, and stuff like that. So it is an open source language. It's still, it's going to be a no license charge and optional SNS product. And it's growing very fast right now, right? So I think the Go initiative in the Compiler team is really to support enabling users to connect to the cloud, right? It's really a containerization, strategy that we're supporting within IBM. So Go on ZOS, we actually have two statement of directions that we have put out. One is we're actually working on Go, and another one is IBM is actually delivering containers and Kubernetes orchestration on ZOS, and we're working on that as well. And Go is very connected to that effort at this point. But we're looking for customers and other usage of Go if we enable it on the platform. We just started our beta program, so our offering manager James Tang, will be a good contact if you want to participate. And again, this is new for us, and we're wanted to get more feedback as we make sure that we're in the right direction. So here are some resources that I put together. It's a lot of information. It's a very short time. So hopefully you can get to read up a little bit more. And that's all I have today.
This is awesome. Thank you so much, Roland. Any questions? I don't see any questions here at the moment. Please feel free to ask a question or just put it up on chat. Paul, do you see anything on the YouTube live stream in the meantime?
There's no questions from YouTube at this time.
Okay. Roland, I just wanted to say, the picture where you talked about and said, bring the whole picture together, put it all together. Quite literally, it is like an orchestra, right? Everything has to sort of play together really, and it all comes together then for you to be able to leverage all the power that COBOL already has to offer, but bringing all these more contemporary languages and tooling as well together. Love that slide. Thank you.
Yeah, and also the hardware support, exploitation, everything else plays into the entire platform as well.
Absolutely.
I always enjoy these presentations because I learned something new. The pick you is rather fascinating.
Yeah, it's something that customer has been asking for, and I didn't know the first use case, that first reaction from that conference when I announced it was emojis, but I guess it's getting important.
And I did post all of the UTF-8 emojis link in the chat area, Roland.
Yeah.
Yep. Thank you, Paul. That was really interesting. Who knew? Absolutely, Roland. Good tidbit there. Yes, so the presentation and the replay of this session will be available on our IBM Developer COBOL Hub page. I just shared the link once again for where we have and host all of our replays. So please come back and check out the replay there as well. Yeah.
We did get one question, and it may not be totally in line, but the question literally is how to install Python and Node on ZOS.
Very simple. There's two things that you can do, right? One is we offer it in a PAX format that, you can just download, but it will not be, it's basically, you can just install it like, like you do on the Linux platform, but it will not be counted in the inventory. You can also order it from Shop Z, which will be an SMPE format that everybody knows on Z how to, it's really the same way as you install everything else on Z.
And if I'm not mistaken, Roland, I realized that there was a Python, but now there's an IBM Python that runs in the ZOS environment. So there were two different flavors.
Yes. Before we do we make Python, the IBM Python, I'd say. There's a partner that also produces Python. That was, before our effort started, and that's Rocket. But the strategic one on the IBM platform now is the IBM Python. I think I'll encourage everybody to basically use the IBM Python, because we're working with Rocket, to move our customers over to the IBM Python as well.
Thank you, Roland.
There is one question over here on our chat, Roland. So Bert was asking, so one can embed all of these languages in a COBOL execution. That's a true statement, right? Specifically Node.js and the NPM.
The NPMs are really Node NPMs, right?
Yeah.
And the way that Node work with COBOL is really through APIs at this point, because it's very different environment. So COBOL, it's not able to work directly with Node, but through API calls, right? That's how we work with Node. Like, for example, you can actually prototype some of the work that features that you want to implement in the COBOL applications with Node. Like, for example, you wanted to whip up something really fast to generate a report, for example, right? Putting it in COBOL will take a little bit longer, but in Node it'll be a lot easier, because it just retrieves data and it put it together in a format that you need. So the way that it works is like it will extend the capabilities of the COBOL applications, but the interaction between them is going to be through API or JSON or things like that.
So he has a follow-on question, and actually he said, I was wondering more about Python, but the follow-on question is, can one embed C and Python make calls within COBOL while on the ZOS platform?
C and Python can be embedded. Python and COBOL, again, it has to be going through some. It's no direct embedding that's going to be there, but yeah. But you can actually, theoretically, you can use interlanguage calls with C and then use it with Python. It's going to be a little bit indirect rather than a direct embed.
Got it. Awesome. Thank you for the question, Bert. I see I have a question here. Give me 1 second, Roland. I noticed PICU for UTF is a feature. Is it, or will this become a part of COBOL standard? Or what other influences will IBM have on the standard?
IBM has a representative in the standard, and IBM will, the direction of IBM for all this work is, a COBOL work is really to support the standard, right? And if we have any new suggestions, we will work through the standard. But we also, would also provide some reasonable extensions to the standard. But the general principle is to follow the standard, but we may want to add some extension. I'm not quite sure whether PIG-U is part of the standard, but I suppose it is. But let me check that and get back to you on that one for sure. I think it is, but I'm not 100% sure at this point.
Excellent. All right. Any other last minute questions on your end, Paul, on YouTube?
There was someone that suggested that IBM produce a video of how to install Python and Node, and I can probably get someone to do that. And I just responded to that.
Okay. All
Okay.
right. Thank you, Paul. All right. No other questions here. Thank you so much again, Roland. This was super informative. This was really, really a wealth of information that you shared here with us, and no idea how 45, 50 minutes flew by. This was very interesting. Thank you for sharing your expertise here with us on COBOL Fridays. The next COBOL Friday is going to be 2 weeks from today on October 16th. And we will have a continuation of our modernization journey with Armin Kramer from .dev, a client story. So I hope you all will come back and tune in to listen to pretty much everything that Roland shared here. But from a client's point of view, how have they actually leveraged all of the modernization piece and seen the benefit or reaped the benefit of it? So Armin will be here to share that story with us. So until then, have a good rest of your Friday. Stay safe, stay healthy. Bye, everybody.
Thank you.